My dear lovely students, how are you? I hope you are quite well, happy, healthy, and your study is going very fine. Today, we are going to start the method of preparation of aldehyde. This is lecture number 2, and we will do here the calcium salt of acids and second from the fatty acids. Okay, with that whole process, we understand here. Once you understand, please like, share, and subscribe the channels. So let's start. This is lecture number 2. That the first we are going to understand here uh, MOP, method of preparations. Okay, uh, and the first we will understand here from calcium salt of acid, right? From calcium salt of acid. So from calcium salt of acids, and then how, see here, we'll take here 2 moles of formic acid, okay, and which is reacted with the calcium hydroxide. In the presence of calcium hydroxide, so what will happen, and when we will supply the heat, students, water will lose and we'll get that HCOO all 2Ca, right? So what happened when formic acid we have taken in the presence of calcium hydroxide and supply the heat, water is lost and you will get the cal formate. Okay, similarly student, suppose you have taken that 2 moles of acetic acid in the presence of calcium hydroxide, supply the heat, water will lose. So what happened in that case, you will get that CH3COO all 2Ca, that is called cal acetate. Okay, now see that what will happen when we'll take that now here is that, see how it will be happen once you form the cal formate or cal acetate, then you can see that how to obtain the reaction. See here, obtain the product. First I write here same reaction, same cal format I write in such a way, H C double bond O O H C double bond O O, and here is the calcium. Okay, so and we supply the heat. So what will happen, students? Here the bond will be, when we supply the heat, what will happen? That the calcium carbonate will release and the compound will form the formaldehyde. Okay, correct? So have you understood what we have done first? First we form the cal formate, cal acetate, cal propionate, like that in the presence of calcium hydroxide, and then we will do that, follow this step and you will get the formaldehyde. Students, one more example here. See, if you want to obtain a mixture of compounds or a large compound, you can do like that. See here, R C double bond O O, R C double bond O O, and here is the calcium. Here is one more compound. So O C double bond O, O C double bond O, and here is the R R. Okay. So what happened? Understand here. Through 1 moles we have taken here. So here is that, see, here is the calcium side you have taken, this side you take the oxygens. Okay, and next is that if you want to take, here is that oxygen, you will take the calcium. So what happened, student, what I'm telling you, if you want to take like that, if you want to take the oxygen from this side, you take the CO from this side. So what will happen, and when we supply the heat, see, RCOR, correct, here is RCOR, means 2 moles of R C double bond O R you will get here. Okay, along with that 2 moles of calcium carbonate. Student, either you can take here the hydrogen also, any group you can take here. So any group means methyl, ethyl, propyl, whatever you want you add according to desired product, you can add here and you will get the desired product here. Okay, so let's understand here how to obtain the ethyl methyl ketone? How to obtain ethyl methyl ketone? What? Ethyl methyl ketone. How to obtain? Students, see here. Ethyl methyl ketone. First, I write here. So, what the ethyl methyl ketone? CH3 C double bond O CH2 CH3. This is called ethyl methyl ketone. So, how to obtain, students? That's so simple. This side you write the methyl, this side you write the ethyl, or this side you write the ethyl, this side you write the methyl. Okay. See here. I write the example here. CH3 C double bond O, CH3 C double bond O, and O, and here is the, okay. Similarly, we write here the calcium O C double bond O, O C double bond O, and here is the CH2 CH3 CH2 CH3 we will get. So exactly what I said in this above step, same thing you do it. If you want to break from here the calcium, you take here oxygen. If you want to oxygen break here, you take the from here the COO group like that. So it means we are going to write here, okay, and we are writing here. So what happens, students? We'll get that when we supply the heat, we'll get that CH3 C, here is the C double bond O, and CH2 CH3. How many moles? This is the 2 moles you will get that, plus 2 moles of calcium carbonate you will get that. Okay. So I hope you understood this, how to obtain like that. If you want to form the mixture, you can obtain the mixture of compound. See here what I am telling you. Students, now the point is, if you have a calcium salt of basic acid, if you have, see here, calcium salt of dibasic acid. If you have calcium salt of dibasic acid, I mean, suppose either 1,4, 1,5, 1,6, 1,7 like that. Suppose 1,4 and higher, 1,4 and higher, because lower will the highly strength. On distillation, what you will get that on distillations? You will get that cyclic ketones. You will get that. What? Cyclic ketones. See here, student, what I am telling you. How to get the cyclic ketones? See here. Suppose you have we have taken CH2 COH. Okay, and here is that CH2 COH. This is called adipic acid, right? It is a adipic acid. So when you take the adipic acid strands and we supply the heat, see here what will happen. Here something will like that. OH, Cl, CO2 will loss first of all, and the second is that here is the OH and H will loss, means carbon dioxide and water will loss, and you will get that here these bonds will combine here, okay, and you will get that students, here is cyclopentanone, okay, you will get that ketonic group plus CO2 and water, okay. So the cyclic compound will form. I hope students you understood that method of preparation of ketone. Here you will get the cyclic ketones, and here is also you will get the ketones, okay, and you can get the aldehydes. How? Suppose both the positions here, and here is that HH, you will get the formal aldehyde group, correct, na? So it's depend on what you have taken in the both side. Okay. Now next preparation is strengths. What the next preparation? This is that thermal decomposition of carboxylic acid. Second is, here is that thermal decomposition of carboxylic acid. Okay. So thermal decomposition of carboxylic acid, what I am telling you, students, see that whenever we talk about the thermal decompositions, we will use the reagent MnO and 300 degrees Celsius temperature. Okay. See here how to obtain. First R C double bond OH. Okay, and here is one more HO, C double bond O, R dash I have taken here. See student, when we supply the heat in the presence of MnO, it means we are using here 300 degrees Celsius temperature. Okay. Some books we have given the 573. Obviously 300 degree plus 273 you will add it, you will get the 573 Kelvin. So what happens students, here is you will get that OH and H will convert into the vapor when you supply the heat. It will convert into the vapor. Here is another, you will get that vapor, and you will also get the CO2. This is also vapor. CO2 will convert vapor and H2O will convert. Means H2O and CO2 you will get the in terms of vapor. So what you will get that R C double bond O R dash you will get here. Now one more. Just can see that example. When you take here what CH3 C double bond O OH. Okay, we have taken here acetic acid, and second molecules will take here the formic acid. Can you tell me what happened 300 degrees Celsius and we give the MnO. This is the reason the thermal decomposition, because we have taken the metals like that. So what happened, OH and H, first we convert the vapor, and the second CO2 will also convert the vapor. CO2 will convert, and this is also will convert into the vapor. So you will get that CH3 C double bond OH, this is the acetaldehyde. So you will get that here acetaldehyde. Still my question here, you will get the only acetaldehyde? No, you can also get that here CH3 C double bond OCH3. Why? Because suppose 2 moles you have taken the acetaldehyde, you will get this compound, correct? If you take the 2 moles of formaldehyde, you will get the 2 moles of 2 moles of formic acid. 2 moles of formic acid you will get that. You will 2 moles of formic acid you can obtain the formaldehyde. 2 moles of acetic acid you will get the acetone. So 2 moles of acetic acid will get the acetone. 2 moles of formic acid we get the formaldehyde. So you can obtain the mixture of compound when you take the 2 different compounds. Okay. Now see here one more reaction I give you. Here is Mn toluene we have taken, and toluene's MnO air, we have taken here 500 high temperature, you will get directly student formaldehyde. Why I am telling you, because most of the students using the ITART process, right? Okay, you can take in the conversion ITART reactions, but if you know the shortest way, that's very good. So sometimes the question is coming not more than 2 steps. When you go more steps in the conversion, that means your conversion will be lengthy and maybe wrong. So the one questions I am telling you, which is exactly same question, that is in the old book, this is a 12.15 question, and the new book I think in the new books 8 or 9.5 I think. So 12.15 here's questions, and that is the benzaldehyde to benzophenone. Benzaldehyde, this is conversion, benzaldehyde to benzophenone. How you will get that? Student, benzaldehyde to benzophenone. See that. You can obtain in a 2 way. See first, what will happen? We'll do the oxidation, and you can get that benzoic acid. Okay. Once you get that benzoic acid, you take the 2 moles MnO and 300 degrees Celsius, and you will get that. Okay. So and the second process is that you have taken the benzaldehyde, and first you do that oxidations, and you will get the benzoic acid, and then you take the any reagent like PCl3 or PCl5 or like that, and you can obtain like C double bond OCl, and then you take the benzene in the presence of anhydrous AlCl3, and this is the Federal graph like that, and you can obtain here. So you can see here, this is the longest way, strength. So if we prefer that simply, first we obtain the benzoic acid and then MnO 300 degrees Celsius temperature, you can obtain in the simple way, in the one step, you can obtain this convergence. Okay. So I hope you understood all this process, the 2 method of preparation we have done. Okay. Next we will study students from the diols or polyols, that is a melaprade oxidation we will study in the next lecture. Thank you. Have a nice day. Take care of yourself.